If you saw my talk last year, this is in fact almost exactly the same slide. So what's the point? What are we doing here? What we want to do is, as the Tpetra performance team, take ownership of Trilinos performance. So we want to avoid surprising the app teams. I don't want to get frowny face Malachi and Heidi. That would be sad. We also want to reduce initial setup times for trying to get on the system, right? So James Elliott is the one source of truth for all things LCAP 10. But he's also a single point of failure. I don't want to have every application person, every Trilinos developer have to email James, because he might get a little salty, and we don't really need that. So should be recording. Is it on there?
Yeah, it wasn't on. Someone turned the mic off. I thought we weren't supposed to turn the mic off.
Who turned off the mic?
Okay. Anyway, so to repeat for the microphones, we want to take ownership of Trilinos to avoid surprises. To make it easier for people to get started, right? We want to have a one-stop shop for how do I build on El Capitan, or how do I build on whatever, and I can just point them to the repo that has, hey, this worked last night. Again, APT as in the person of James Elliott, coordinating with them. Look at behavior across time, so we want to think about regressions, but also across different systems, so to see what performance looks like. Provide ways to let people know when it's safe to update Trilinos. And I put this sort of in italics because this is new this year, to coordinate better with the Cocos and Cocos kernels team on performance. And so those are the folks who are working with us. And what do we mean? What are we focusing on, right? There's a bunch of different things. So we're going to look at CPU systems. So these are CTS1, CTS2, and then Crossroads-like systems. AMD GPUs, so it's Frontier and LCAP-like systems. NVIDIA GPUs, and then, of course, good old Aurora. The new one this year, which is only a couple weeks old, this is Kernus. This is our H200 machine. We got our initial performance tests up, I think, day 2 of early access time. The fact that it's binary compatible with hops helped. That stuff mostly worked, and then started actually working, kind of moving out from there. So what's new? Our soon-to-be open source replacement for our Watcher performance monitoring system. So Dane, you can wave for anyone who hasn't seen Dane before. He's going to talk in the next slot and walk through what this is. So the paperwork of this Warden system is ongoing, so I'm not going to show too much to that, although you see the occasional screenshots. Performance testing with Cocos kernels. Some improvements inspired by the HPSF Benchmarking Working Group. Kernus, which I just showed you, and I'll show you more. Performance testing of Balos and Zoltan 2, which we didn't have last year, and then refinements to existing tests. So I'm going to focus primarily on the stuff in the middle. If you have any questions about the other things, you can certainly catch up with me offline. So let's start off with Cocos and Cocos kernels performance testing. So what our team did was develop a way of converting our sort of Trilinos style timers and then the G-test, G-bench style timers and making them work together. So now, when we turn on our dev Cocos builds, we now get all of the Cocos performance and Cocos kernels performance tests as well. So we've got builds that do Trilinos with a version of the day, Cocos and Cocos kernels snapshotted in on CPU, on NVIDIA GPU, and AMD GPU. So it's 3 systems, a subset of what we're doing. And this is an example of what we'd see. So this is a running average, the red line, so the blue stuff is what you want to look at. And this is the view allocate test. So what we did is, because Cocos kernels has a ton of different variations of each test, we sort of sum them together and nest them artificially so that we can basically look at one thing. This is, if I were to click down on view allocate, I would see all the different allocation sizes and whatnot. But one of the things we were able to pick up was, in fact, hey, Cocos got faster. Now, it turns out that this example was, in fact, a nothing burger. So if I let it go another day or two, it would pop back up to where it was. But this is the sort of thing we can pick up. Like, hey, there is a change in Cocos that makes a real impact on their performance on version of the day, so we don't have to wait for the Cocos promotions. One of the things we're hoping to do is get this sort of thing in the hands of the Cocos and Cocos kernels teams, so it's not just us looking at it. They can look at it as well in their own regular meetings. Benchmarking Working Group inspired improvements. First one is annotations. So you can basically see these little dashed lines, you mouse over and you'll get something like this. This is something that the Chapel team totally shared with us and we thought was awesome, so we did it. So that gives us a way on the performance tracking system to record changes and say, oh yeah, like it was this PR that did blah, blah, blah. Or, oh yeah, this is when we updated Cocos. Right now this is all manual. We're hoping to automate some of it, like Cocos snapshotting will automatically, hopefully, annotate and stuff like that. But it's there in a way that we can now look at it rather than have to look through our meeting notes, which are in a separate repository. The other one was alluded to earlier, our recording a machine state. So we're getting all sorts of stuff out. Environment variables of relevance, LDD output, your SMI stuff, and then stuff from LSCPU modules and sensors. So specifically, this is one of the snapshots I could put that no one would complain about in a picture. If I had gotten stuff with like more LDD stuff, you start seeing path information, and then someone would get moody about that. But the idea of pulling stuff like not just from the SMI tools, because that lets us test driver version, because if the admins update that and that changes something, that's important. And then the LSCPU, et cetera, and sensors, this is also going to potentially allow us to detect clock speeds. So we're not doing anything with this information yet, but the idea is, sometimes you have this note, like this little one-day blip. As it turns out, you look at that, you'll be like, oh, it was just a bad day. But in theory, with this information, we might be able to quantify why. Oh, it just was too hot, or it downclocked. So the idea is, what we want to do is take this and be able to stick an asterisk next to that to say, there was a system anomaly. We don't need to worry about this one-off day. Without having to say, normally what we do now, if we were here, we'd be like, oh, it got bad. Well, let's wait till next week and see, right, to see if it's a one-off. But hopefully we'll be able to catch that sort of thing faster. The other one is Kernus. So this is some initial results, which included some actually pretty bad results, but it works. So you've got Perlmutter here, so that's your A100s. There's hops H100s, and these are H200s. They're faster now. So this is the first week. It's like 4 or 5 days worth of data. They reconfigured the machine since, and now these numbers for Kernus should actually be a little lower. But the fact that we were able to get these sort of things and pull up comparisons within the first week of early access is pretty cool, enabling us to kind of get going and see improvements. Right? This has more memory bandwidth than hops does because it's H200s versus H100s. So in theory, we should start seeing it pull ahead once you start doing big jobs. But this is the sort of thing we can do. There was a ton of performance-driven improvement to Tpetra. Christian Glusa drove a lot of this. If he didn't get enough credit from Roger before, he can get some more now. So there was a mess in sorting in terms of different algorithms being used in different places, Cocos kernels not being utilized sort of consistently, and we have tests that did not actually reflect real-world applications. We were testing matrix multiply with random matrices, which is exactly what you want from a regression test. As a performance test, not so useful. And then there was Cocos kernels did not have a sort that performed particularly well on CPUs. And so Christian, along with folks on the Cocos kernels team, have been sort of working on cleaning this up and giving us more options. But the fun part about this, and the thing I wanted to point out for this discussion, is because we have this daily performance monitoring, Christian had to touch a ton of stuff to do all this. And what he did is he basically timed it for 1 PR a day. He would put in a PR, he'd let all the stuff run overnight to look at the performance tests, and then would look at it in the morning and say, okay, this looked good. This didn't screw anything up. Nothing weird happened. Let me now move on to the next step. And so he was able to sort of dribble out his changes such the performance system could offer feedback. That's not optimal, but it's still something we couldn't have done, say, 5 years ago. The other fun thing we managed to do is actually make improvements to Cocos. So this is finite element assembly, and this is the actual Trilinos level test, and that's where we integrated Cocos 5. Oops. So we caught this on the integration with the performance tests, and it turns out this all boils down to subview creation. So we looked at this, we saw this, we're like, oh goodness. We went to Christian Trott, he stared at it, and this is the quote that came out of the issue that wound up getting filed with Cocos. So basically, it was subview creation got a lot slower, and this test happens to create a lot of subviews. And so it was to the point where it was visible, right? This is probably about 5%-ish. 5% slowdown in the overall test that was actually visible. And so Christian helped track it down and then remedied that improvements to the next version of Cocos so that the subview creation was faster, and it bypassed a whole bunch of these increment and decrement calls that we didn't actually need, which is pretty cool that we're able to get that feedback to the Cocos team. So where are we going for the rest of the year? So one of the things we've been moving to is trying to do more stuff with GitLab runners over Jenkins and cron where possible, right? There's plenty of places where it's not possible. Cron is all you have, or even worse, scron. So one of the goals here is to allow team members to partially performance test a candidate branch with a few clicks. Rather than have Christian have to wait and do one PR per morning and let the system run, ideally, he'd be able to just go to the GitLab dashboard. Well, maybe not Christian specifically, but someone could go to the GitLab dashboard, click a button, and say, go run the performance test on this branch, to be able to get that sort of feedback when you're doing these like sort of sweeping internals of Trilinos sorts of changes. Getting a Cocos kernels only Warden dashboard for those teams. We talked with Christian and Damien last week. They seem pretty excited to do that. Luke is going to be our sort of guinea pig for that with the Cocos kernels team. Giving the data we're already getting, I think where they really like to go to that is be able to augment that with their own data from their own internal testing. So they can actually do something with all the performance tests they run and never look at. Improving automatic distribution, so better connecting SHAs and commits. That's been a little bit of a challenge. And then automatically detecting and annotating changes in system state. We collect all that information right now, and that only gets human reviewed if we need to. And then finally, kind of continued incremental improvement on GPU performance, which a lot of the stuff that Christian had done was driven sort of by those things. And that's what I got, and I'm more than happy to take any questions. Thank you.
We have time for questions.
Everybody loves it. It's great.
How easy is it to set up a warden stuff?
All right. Well, I'm going to defer to Dane, who's going to tell us more about that in a minute. But what do you think the suffering level is to set up a warden?
Right now, it is not possible. So, but it should not be that hard. Honestly, you just clone the Git repo, and it should just be like a make. You just need Podman essentially. Not one.
So, Chris, so it sounds like you wanted to use the performance test as a means to quickly assert performance from PR, right?
Yep.
So, is there an idea on like how you could turn this into like a special category on the PR tester so that it would only fire it off maybe on like quicker or something, so that you would have like, I don't know, some way of like development and triggering this just for the sake of performance?
So no, because that involves stepping into the cybersecurity mess that I don't want to step into. I think what we'll probably wind up doing for the one-click button is we'll probably do it running from like some mirror on like one of the internal computers, right? Because we're running on all these internal Sandia machines, right? And so that gets the whole can we post data outside, et cetera. So
I just found it interesting that you're doing a PR, a pull request, right, to infer performance like that. And it seems like something in that suit could get optimized in a sense where developers could do that.
yep. If we were yep. If we were only running in the cloud, I think that would be the right way to go. It's just there's all the, because we're running on the internal servers, there's all the sort of cyber issues that, to be frank, I don't want to deal with right now. Let's get something working, and then, I mean, you can talk to Sam about what a pain the cybersecurity concerns are, and they're legitimate, right? I'm not knocking on them because they make it inconvenient to do my job, right? Like they're real concerns that would have to get worked through to be able to do that.
General productivity,
Mhm.
where if we had that capability,
Yep.
or if that was something we could figure out, that would be pretty slick, right?
Yep.
So,
Yep, I agree.